Hi, this is Tim Hegarty with the virtual training company C++ Fundamentals. We are looking at now static cast operators. A static cast operator is used to force a cast, and you as a programmer have to make sure you know what you're doing with this. And since this is just a fundamentals area, we're just going to look at this for a minute because you're stepping over or your bounds and could literally overstep your bounds by using a static cast to force various kinds of pointer conversions, which we'll see in the next slide here. But first of all, let's just say that we have a little bit of a program here that is going to allow us to show static cast operators. So here we have a character ch, an integer I, a float f, and a double. So we can do a static cast, and you can see we're going to cast a char, and that's of I. So we're going to take this integer I and we're going to force it to a character and put it into ch. And a static cast does not do any kind of runtime checking or anything else to make sure that this is sensible or legal or even possible. So you're on your own when you use these. And here's another one. We're going to static cast to a double from a float. So we have double inside the less than greater thans, and we're going to take our float and cast it to a double. And here we're going to do a static cast of a byte, and you can see we have a new type there, which we did it in a type def. So that's just an unsigned character. So we're going to take ch, which is our normal character, and force it with a static cast into I, and that will be an implicit cast there, which we've seen in other parts of our tutorial, but rather than the forced static cast. Now here's where we use a static cast to cast pointers up and down a class hierarchy. We've created a class called B, and then we've created another class called D, which is derived from B. So D is a superset of B. It is larger and could have, most likely does have, more methods and members in it than B had. So we have to be careful in banding about pointers between these two. So now we have a function called f, and it will take in a b pointer called pb, pointer to b, and it will take in a d pointer, pointer to d, pd. Well, here this is an unsafe static cast, but you can do it. No runtime check is performed. What they're going to do here is they're trying to cast pb, which is a pointer to b, as if it were a pointer to d. And remember, d is larger. It takes up different memory. It has a different layout and could have different access specifiers to its methods and members. So by doing this, the compiler will do it and put this in PD2, but if you use PD2 and this did not point to the exact structure, the class, which we know are just superstructures from C, if you don't point to exactly the right kind of structure, you could blow the world away. Now down here, this is okay. This is a safe conversion because we are taking the D pointer, which is larger, and casting it down to a B pointer because the B pointer is within and wholly contained by the D pointer, or by the D class. The B class is wholly within a box within a box. It is within the D class. So it's okay to cast a D pointer to the bigger box as if it pointed to the smaller box because we know that that will fit, and we can put that into PB2. Okay, so just be careful with a static cast, and again, in the fundamentals, I hesitate to even bring it up, but it's something you're going to see in code, and you want to see what it's doing. It is forcing a cast of an expression to this type and then returning the result of that type.